So as we look at points on a terminal side, let's refresh our memories on what terminal and initial sides are. So the initial side is simply your x-axis. It's at 0 degrees, right? And as my angle opens up, so as my angle goes in the positive direction, wherever it stops is my terminal side. So right now, this is my terminal side. If my angle keeps going around, maybe this far around the circle, then this would be my terminal side. So it's wherever it stops. Okay, so let me get rid of that. So if I give you the point -8 square roots of 17, that is going to be in the second quadrant, right? Because -8 positive square roots of 17. Don't spend a whole lot of time evaluating exactly where that point is. You don't need to draw it that accurately. You really just need to know what quadrant you're in. So this is my theta at this point, right? This is my theta is right here, but I really can't do anything with that, right? I can't really make a right triangle out of that. I don't know how to, reference something like that, but I can use trig if I can make a right triangle. So that's why we draw these reference triangles. So I'm going to drop straight down, or below the x-axis, I go up to the x-axis. So draw a right triangle going to the x-axis, and then I can label my right triangle. This length over here is -8, and this length here is the square roots of 17. Right, because I'm going back 8 and then up square root of 17. Then I can use Pythagorean theorem to find the third side, or the radius in this case. So this is 9. Okay, if you can, I'm sure you can do the Pythagorean theorem, and you end up getting 9. So now, and oh, by the way, the radius is always going to be a positive number, or your hypotenuse will always be a positive number. So now, if it helps, and I think it helps me, I know. I like to write O over H, A over H, O over A, and then remember cosecant, secant, and cotangent are just flips of all those. So H over O, H over A, and A over O. It just helps me to write them down. So now, if I were to ask you for any one of the 6 functions, generally a test question or a quiz question might just ask you for one of them. It might just say, what is the secant of the angle going through the point -8 square roots of 17, or something like that. So, but I thought it would be good practice to evaluate all of them. So sine is simply opposite over hypotenuse. So I'm going to get square roots of 17 over 9. And if you can simplify them, do so. That one doesn't. A over H is -8 over 9, and O over A is square roots of 17 over -8. And I can't really simplify any of those. So now what I'm going to do is cosecant, secant, and cotangent. I'm simply going to flip every one of those. So that's 9 over square roots of 17. Secant is 9 over -8, and cotangent is -8 over square roots of 17. So I can't really simplify them, but you guys should notice that I've got this is square roots of 17. I've got 2 radicals in the denominator. You do need to rationalize your denominators. So for cosecant, that is going to be 9 square roots of 17 over 17. So that is your final answer. Please don't leave square roots in the denominator. And cotangent, if I come over here, that is going to be -8 square roots of 17 over positive 17. And that is your final answer.